Okay, in the last video we learnt how to calculate the angle of that servo and the angle of that servo to place that foot in a certain X or Z coordinate. Today we're going to learn how to calculate that servo to place the foot in a certain Y coordinate. Right? So before we had this set up, you're familiar with arm 1 and arm 2, but there is actually an arm 0 we haven't talked about. That's this little arm here. So we have arm 0, arm 1, arm 2. And that's our front view like that. If we get our front view and roll up on top and look down of it, we will see something like that. Right? There's our arm 0, our arm 1, our arm 2. Now we're trying to calculate what this angle here is. I've called it theta 9. Now we know tan theta 9 will be equal to opposite over adjacent. So tan theta 9 will be equal to y over x. I have to write that down. Tan theta 9 equals y over x. Therefore theta 9 will be equal to the inverse tan of y over x. And voila, we've calculated that angle. But the trouble is, as we just shift the arm down, this foot's going to swing in and end up at a shorter y component, a shorter x component. To keep the x component the same, this foot actually needs to move out as it swings down further and further down to remain at the exact same x coordinate out. So what happens is we need to calculate what the new x is going to be. Now we know this total length here will be equal to the hypotenuse of that triangle. So x squared plus y squared will be equal to the total distance. Well, the total distance will be equal to the hypotenuse of x and y. Right? And we can do that in code pretty easy like that. Total distance is equal to hypotenuse of xy. Now we know that this distance here we're going to try to calculate will be equal to the total distance minus arm 0. So I've wrote that down. The distance we're going to calculate will be equal to total distance minus a0. So we know that total distance is the hypotenuse of xy, so we can say our calculating distance will be equal to hypotenuse of xy minus AO. Okay, let's look at some code. All right, you're familiar with this whole bottom routine. It's exactly the same as what we were before. I have only added 2 lines of code to calculate this new angle. The first one, theta 9, is equal to the inverse tan of y over x, just like we just said. The new value for x will be equal to the hypotenuse of xy minus AO, which in my case is 26.5. Right? Then what I've done is, as you come down the bottom here, I've made 2 loops. Right? For y, from negative 50 to 100 stepping by 2, update the body position, that'll go right through, and then I loop through in the other direction from 100 back to negative 50. So that will basically just move the foot in the y direction from negative 50 to 100 and back again. Alright, so let's have a look at some code here running. When we run that, get a good angle so we can see them. Run code. See, and you get the robot at a nice straight angle. Let's run that again. And it keeps that foot all at a beautiful angle, just going straight and backwards and forwards, keeping the height the same, keeping the x the same, and just changing the y. Alright, so in my next video, I'm going to step back a little bit